Hello, and welcome to this OpenTopography tutorial. Today I will answer the question, how do I process larger data sets in OpenTopography? There are several methods which I will be discussing today and are outlined here. First, you can download pre-computed raster datasets instead of point cloud datasets. You can download point cloud datasets in LAZ format versus LAS. These datasets are much smaller, will download more easily to your computer. You can process ground points only, and this is appropriate for geologic studies focused on the bare earth, and will also let you access more points or a larger area in a single job. You can tile datasets to process quite large areas via the OpenTopography portal. And then if you really are interested in big areas, then I highly recommend using bulk download and API. So to begin, raster datasets. So on OpenTopography, with OpenTopography datasets, you can, in a single job, process and download up to 125 square kilometers of raster datasets. And for the far majority of datasets, this will be quite a bit larger than what you can access in a single job of point cloud data. And to access these raster datasets, you'll want to go to the dataset selection and say get raster data. And I'll now show you how to do that on the OpenTopography portal. So here we are at opentopography.org. Do recommend that you create an account and then log in. This gives you higher access to data, larger data sets at a time. Then you can go to data. And then in this example, we're going to be looking at Hawaii and the Kilauea volcano. So we'll go to select a region, which is here, and then put the box over the area of interest. And then below we can see the data sets that are available. The first that come up are these OpenTopography hosted LiDAR data sets. And again, you'll want to select the get raster data over the get point cloud data. And again, this get raster data allows you to process much larger data sets in a single job. We can come here. We see that this area has 36 square kilometers, which is below our limit of 125 square kilometers. And then here you have only the option of processing a digital terrain model. The other way to process raster data sets is to use the USGS 1 meter DEM. And you can process data sets at a single job of up to 500 square kilometers. And this data set is available only to academics as well as OT Plus subscribers. And to access this data, you'll want to look in the Global and Regional DEM tab, and then come down here where it says Academic Access and OT Plus. And there you'll see the USGS 1 meter digital elevation model. Now, data sets that are open to all also include this USGS 10 meter and USGS 30 meter models, which are not high resolution topography, but are useful for many applications. So I'll now show you how to access this USGS 1 meter data via the portal. So here we are back at OpenTopography and at the data tab. And let's go to New Mexico. So we want to look generally in these areas with green data sets. We draw our box, and then we can come here to Global and Regional DEM. And then we can see that here we have the USGS 1 meter digital elevation model, which we can access by clicking this button. The area selected was too big. And again, we are limited still to only 500 square kilometers, which now this area is under, so I can process this area on OpenTopography. Now, there are many cases where you might want to actually download and process point cloud data. And I do highly recommend that you download LAZ files instead of LAS files, as LAZ are often 10% or less the size of LAS files. To make this easy, LAZ is the default option for point cloud processing, and if you wanted LAS, you would have to click here in the LAS button. To emphasize the size difference, this is looking at the same job, and we can see that the LAS is 4.4 gigabytes and the LAZ is 0.3 gigabytes again. So the LAZ is less than 10% the size. This does make downloading it and putting it on your computer easier. Just a side note is that different codes will sometimes require that a point cloud is in a specific file type, for example, LAS or LAZ, but not the other file type. And so if you're having trouble reading in point cloud datasets, I recommend that you look into the documentation and see if a specific file type is required, or just trying the other file type can sometimes get the point cloud file to be read appropriately into the computer. And another option is to process a digital terrain model or bare earth, so to process the ground points only. So this is looking at an example of a data set in Austin, Texas, and the full point cloud has a point density of about 13 points per square meter. And we could process this full point cloud, and the area that I selected had roughly 200 million points. Alternatively, we could look to process just the ground points, which again may be appropriate for many geologic studies. And in this case, selecting only the ground yielded 18 million points. So we see here that only 10% of the points are classified as ground. And this is just generally worth keeping in mind to understand what your point cloud dataset means, and specifically that most of the points are not ground, so they're vegetation or buildings or other features above the ground. But if you are interested in those geologic studies of the bare earth, you can process roughly 10 times larger size by selecting the ground points only. And I'll show you now how to select ground points only on the portal. So let's go look at that data set in Austin. Select a region, put a box over an area of interest, and then here we see that data set. Get point cloud data. You can come down and in this first coordinates and classification window, the default option is all points. And this area of selection, we have 76 million points. We could select only ground. And to do that, we'll first click this standard classification. And then that shows the classifications that are available in our data set. And in particular, we have ground and unclassified. And we can turn off the unclassified points. Now we have only 7 million points, which means that we can process a much larger data set before hitting that 350 million point processing limit imposed by OpenTopography. The next method I'll discuss is tiling. So in this case, if you want to process a data set that is larger than you can with any of the methods that I previously described, you can do tiling where you process multiple adjacent data sets. This does get long and there is a lot of bookkeeping, so I don't recommend doing this for that big of an area. And here I'll show you an example where I did it for doing 4 blocks. And I think that's appropriate, but if I were going to be processing larger data sets, I would be looking at other methods for still bigger data processing. So I'll show you how to process this job. So this is going to be that 1 meter USGS DEM, and here we're looking in the Finger Lakes area of New York. We'll go, yes, we're in data, and then we're going to go to upstate New York. And we'll still do select a region, put that box in. And we see that the default is these USGS 3-point cloud data, but I really want a big data set, so I can do this faster by going to regional or global and regional DEM. And again, for these big data sets, it is worth thinking about if a 10-meter or 30-meter data set could be appropriate. For example, if I'm just looking at making a base map for a larger scale figure, maybe a different global data set is available or is best for my options. But if I want that 1-meter DEM, I can come here and say get USGS 1-meter data. And then what I'm going to be looking to do is to process 4 jobs over adjacent areas and then ultimately merge them together. So each data set can be 500 square kilometers. So to get that biggest size, I do want to try to aim for each job to be roughly that. So I'll put a box. You can see that's 600 or 164. Make this larger. There will be some guesswork. All right, so here we have 428. And then you can come down, set any options you would like. And then I do like to add a good title for these. So I could call it, for example, tile 1. And then I press submit. This is now being processed. And very shortly, I have this option that comes up that says modify and resubmit this job. So this will remember where my last job was processed and will make it easy for me to process an adjacent tile. So I'll click that. And then here is where that last job that I processed was. So now I want to make a new adjacent tile. So we'll zoom in a little bit, select a region, and then I want to have a little bit of a boundary with that past data set, and then select a similar sized area. All right, so here we go. We have 398 square kilometers. So that fits in with the 500 square kilometers. And then this is now tile 2. So I'll say submit. So this is now being processed. And again, we have this modify and resubmit job option that is open. And I recommend that you click that again and then just process the tiles, renaming them intelligently each time. So the next one would be tile 3 and then tile 4. And I already processed these, so I'll show you how to merge them. So here we have QGIS. And here I have a folder called grid data. And I have D1, D2, D3, D4. I had an issue with D2, so I had to reprocess it. But I do recommend that you name them somewhat intelligently so that you can find each tile later, specifically if there is an issue with one of the data sets. So we'll pull those into QGIS. We can just drag and drop. There they are. And shortly we'll be able to see these 4 data sets. They are quite large, so QGIS is taking a little bit of time to load them visually. All right, so we can now see that we have these 4 data sets and they overlap approximately here. But for different derivative calculations, for example, topographic hillshades, it would be annoying to have to run that 4 times. So we can merge these data sets into a single larger file. So to do that, we go to raster, miscellaneous, merge. So again, that's raster, miscellaneous, and merge. And then there's a few options that we want to set here. The first important one is input layers. So that's telling QGIS which files you would like to merge. So you'll click, and then you have the options here. So you can either click each individually, or you can say select all. And clicking select all is certainly useful if you have many data sets that you would like to merge. We can go back and look at our parameters. So we have the option of saving the merge to a temporary file or to a permanent file. Today, I'll just save it to a temporary file, but if you are planning on using the dataset later, then I do suggest that you name it and save it into a real file on your computer. You can say run, and it is now running. So here, the job has finished running. Took a little bit longer than that as I paused the recording. So we'll say close, and then QGIS named the file it just made merged. And we can turn off the other ones. And then here we see our relatively large DEM processed from the USGS data. So let's measure it. That in kilometers. So it's about 40 kilometers long, which is a relatively large data set that we have now processed. So close, and then let's look at a hillshade to convince us that we really did just process that data. Again, we'll keep merged highlighted. Let's say raster analysis hillshade. I'll just run with the default options. All right, so the hillshade has now finished processing. So here is our topographic hillshade, looking at one of the Finger Lakes in New York. So again, this is showing that we can tile data sets and then ultimately process larger data sets still using the OpenTopography portal. And if you're in the case where you really need a lot of data, then I highly recommend that you don't use the portal, that using the ways I've shown you today, and you instead can download the bulk point cloud data using the information that you'll find when you click these buttons at the point cloud dataset pages, or you can request an API to process some of our data sets in raster format. Thank you, and this concludes the video.